Hi there, let's continue our preparation for the IB Mathematics, Analysis, and Approaches standard level exam. This second lesson deals with quadratics, in particular properties of second-degree expressions that are not yet concerned with transformations, trigonometry, or calculus. Give yourself 2 minutes to get a feel for this problem.
We must focus on the equation g of x equal to 0. Let's get this second-degree equation explicitly, where x is a real variable, and k is a real constant. To avoid real roots, we must impose the discriminant of the second-degree expression to be negative. And identifying the coefficients a, b, and c, we find a simple inequality whose solution is the answer for this problem.
Think about this new problem for a couple of minutes.
This time we look for two equal real roots. Therefore we must impose to be 0 the discriminant of the corresponding second-degree expression. Let's be clear. The variable in question is x, and we will obtain the delta with that in mind. To find the value of k asked by the examiners, we must solve a different second-degree equation, this time, k-related. If you recognize this common factoring, we find the value of k immediately, because we know 2k minus 1 must be equal to 0. If you don't feel comfortable about that, consider the second-degree equation on the variable k, and when you calculate delta, you will realize it is 0, as expected. Reason. The value of k is unique, according to the question stem. The calculations presented may be seen as Bhaskara, when delta is 0. If you can see further, you will realize the formula for k is precisely the one related to the x-vertex of the parabola. Think about that, geometrically speaking.
Give yourself 7 minutes for this one, a bit more interesting.
We have 2 points with the same ordinate on the parabola. Therefore by symmetry, we are sure the x-vertex of the parabola is the average of their abscisses, that is, the arithmetic mean of their x-coordinates. Note that the x-vertex of the parabola is a function of the leading coefficient a. The linear coefficient, b, is given. From the previous item, we have a first-degree equation on the variable a. It has the value 2 as its root, as expected. To find the constant c, we explore the fact that point -1, 5 belongs to the graph of the function f.
Think about this new problem for a couple of minutes.
Let's assume that a is different from 0, of course. Do you realize the square, presented in the second-degree expression, guarantees that 15 is the minimum, or the maximum, possible value for the image of f, depending on the sign of the coefficient a? That's enough to justify that the x-vertex is -10, and the y-vertex is 15. We find the value of a, using that the point 0, -20, belongs to the graph of the function f. The same idea, now with the point 8, b, let us obtain the value of b.